On several Facebook groups on robotics, including my own page, Robotics Learn by Building, there's been countless posts from people wanting to get started in robotics. Their questions and posts have been confusing, mostly because they do not understand what it is that they want or what it is they're trying to do. Now, I was there myself many moons ago, and many of these people are like I was, very young and in a place in the world where they simply do not have access to technologies commonly used in robotics, nor can they afford it. I get it. I was in a poor family when I started out, and things like the Arduino or other microcontrollers like the PIC didn't even exist, really. To further confuse the issue, artificial intelligence and machine learning have become so common now that people outside of the robotics world and wanting to get in think that that's just an easy, maybe even necessary part of it all. So I thought I'd throw together this video to show you in a practical way what you can do to get your start in robotics and to dispel a lot of confusion and misunderstanding about what you need in knowledge and in parts. All right, let me start off by pointing out how I got my start in robotics. This video will be directed primarily at those who simply can't afford to get electronic or electromechanical parts or have no access to such things. My beginnings were humble, but I'm kind of glad I went this route now. See, my family was poor at the time. I was 9 years old, and my parents gave me a Christmas gift of a set of precision screwdrivers. I'll be honest, when I first unwrapped it, I was really disappointed. Turns out that was one of the, if not the, best gifts they ever gave me. With that set of precision screwdrivers, I was able to start taking apart electronic and mechanical devices that I collected mostly from the garbage. I would go to the dump and specifically look for electromechanical devices, and I took them apart and kept the parts. I kept everything. The motors, the mechanics, the circuit boards, even the screws and the plastic body panels from the devices. The plastic body panels I would cut up later on and use as body panels or structural components for the robots that I would build. I actually wound up using those precision screwdrivers even as drills as well because I didn't have a drill. Couldn't afford it. And cordless drills that are so common today didn't exist back then. So the more electromechanical things that I collected and stripped, the more parts I had available, and the robots almost built themselves. Now, while the mini computers like Arduino are great, they are so common among robotics discussions that it gives the impression that you have to have one to build and control a robot. This is not true. I've built many robots over decades, and only a couple used a computer of any kind. In fact, the series of submarine robots I built all had a wire going to the surface for two reasons. One, if something went wrong, I wanted to be able to get my robot back. Two, simplicity. Yes, I could put a microprocessor on board, but there was no need. Later, when the Arduino came out, it was quite revolutionary, quite literally revolutionary, because it took very complex microcontrollers and made them simple and available to the common person. The Arduino boards can greatly expand what you do and how you do it, but they are not necessary to enter into the field of robotics. You can get in robotics, you can get started in robotics like I did, get old scrapped machines and electronic devices. Old picture tube TVs and microwaves, I would advise to stay away from for now, as they both have an electronic component called a capacitor, and they can hold a high voltage charge for months after being unplugged. Even when they are unplugged, you can get a serious electrical shock from them if you don't know how to deal with them. I got a jolt from a TV I was working on. It was actually an arcade machine, and that used one of these big picture tubes. And I don't know how many volts I got hit with, but it was right across my chest and threw me back about 3 feet. The only reason I didn't go farther was because there was a concrete wall right behind me. So just stay away from picture tube TVs and microwaves. I was finding machines in the dump that really do not exist anymore. Machines like dictaphones, which had long threaded drive rods. I'll show you how to make these yourself with common, easily accessible parts. Some of the best machines for parts were the old VCRs and photocopiers. Usually, the bigger, the better, the more electromechanical parts they had. Large photocopiers, some even have air cylinders and small compressors. Laser printers are not bad, as they are a lot like a small photocopier. Your typical bubble jet or inkjet printer usually has a few parts you could use, but typically not many. Usually a drive motor or two and a stepper motor. Scrapped cordless drills or cordless screwdrivers are awesome for robotics. I'll show you why later. But if you find a cordless drill that was scrapped because the battery wouldn't take a charge anymore, for instance, grab it. Now, first, I'd like to explain what you should focus on learning and why. The most common questions or calls for help I see involved remote control, building an arm robot, or a flying robot. My series of online courses I call Robotics, Learn by Building, is actually set up in the sequence I recommend learning. I developed that sequence over 30 years of teaching at a science camp and at a high school here in Ontario. When I went to college to learn robotics, it was an entire year before we even saw a robot. We spent the entire first year learning electricity and electronics, digital electronics, programming, math, as well as physics, and I agree with their educational plan. The electronics I learned during that time has been the most valuable asset of all the things they taught. I've used that knowledge extensively over the years. The second college year was very practical, working with actual industrial robots, programmable logic controllers, and industrial machines. But most of what I learned that second year was pretty specific to those machines we were using. And most of it I've never really used in industry. We were never taught skills like prototyping. I was self-taught in that skill both before and after college. And artificial intelligence, it didn't really exist then. ASEA was just coming out with an overhead vision system which could recognize, basic shapes on a conveyor belt to find out the true orientation of parts, for example. But it was slow and crude. But here's my series of online courses which are available on jetpackacademy.com, and I set them up this way because I recommend learning in this order. Course number 1 was on analog electricity and electronics. We start from zero. Assuming you know nothing about electricity or electronics, we introduce the basics. The basics are pretty important, and you will use this non-stop throughout your entire life with robots. We build a lot of electronic circuits and learn basic machine control and power control. We even experiment with bionics. Course 2 is digital electronics. We learn first what digital even is, and then start using little microchips called microcontrollers or embedded controllers, which are effectively a tiny computer on a microchip. We start with a microchip called a PIC microprocessor and do a bunch of actual machine code, learning the language that microprocessors use and why they use that language. At the science camp, we used VIC-20 computers. I'm dating myself there. We move on to the venerable Arduino. The Arduinos are very nice and easy to use microcontrollers with a lot of support because all of the software and hardware is open source. And because you are effectively programming in the C programming language, it's much easier to program the machine code. From there, we learn how to program various digital devices like displays, digital motor controls, read sensors like temperature or position, and yes, we even get our robots doing a little dance party. Course 3 is the course I am working on right now, which is robotic drives and physics. Physics and robotic drive mechanisms are so closely intertwined that they are practically the same subject. We learn all the different kinds of mechatronics we can use to make a robot move and how to use those mechatronics. DC motors, AC motors, stepper motors, brushless motors, hydraulics, pneumatics, and simple machines which become critical in designing robots. Course 4 will be prototyping. This is not a topic you encounter in college or university until your third year. And this is a critical skill that I learned on my own. You'll notice in my personal story, this is actually where I started. I didn't understand how the different kinds of DC motors worked, nor did I understand how to use them. You can't just stick a wheel on a DC motor and expect it to move your robot around. Or so I learned the hard way. Why? That's what you learn in course 3. That's the physics you need to learn. So I kind of learned things backwards in my life. But in this course, you learn a bunch of skills and tricks of the trade in designing and constructing a machine from scratch, even to design it so it can be mass produced. We take all the skills we've learned in the courses so far to design and build a 3D printer. 3D printers are effectively a robot. And once you have one built, you can then also design and 3D print parts for any other robots that you wish to build. Course 5 will be what we call autonomous robotics. Autonomous meaning these robots are on their own in some way, making decisions, or even us making remote repairs like what Jet Propulsion Labs did with their One Mars rover. The robot was on Mars and they fixed it from Earth. How did they do that? In that course, you will cover various navigation methods where the robot has to navigate known or unknown terrain, either in conjunction with instructions from you or completely on its own. We learn how to pick up and use GPS signals, ultrasonic or laser sensing of the surroundings, or even using digital cameras to identify objects and navigate or manipulate. We'll also cover some basics of artificial intelligence. So, the questions I'm seeing asked by those interested in the topic are pretty consistent. Question number 1, how do I get started? My hope is that I just answered that question. Start with the sequence I just recommended. You do not need to know anything about computers or electronics or artificial intelligence to get started. Unfortunately, what I see in a lot of the questions and goals people have is a hodgepodge of a whole mess of very complex topics. And in fact, I don't want to criticize because robotics really does involve such a diverse range of topics and expertise. That's probably why I liked it so much. And it's good to have these goals, but you need to break it down into separate, smaller goals. Which brings me to the second most common question or call for help that I see. I want to build a robot to learn a simple task. Artificial intelligence or machine learning has become such a commonplace topic and often associated with robotics that many newcomers are under the impression that you have to learn it or that it's a key part of learning robotics. Nothing could be further from the truth. The majority of AI and machine learning is never used with robots in any way. The vast majority of AI and machine learning is used in computer programs for things like facial recognition or pattern recognition to interpret handwriting, for instance, or perhaps voice recognition. Now, while it's perfectly understandable for someone to want to learn these topics, and I commend you for it, you just need to understand that there is a distinct dividing line between AI and robotics. They are two completely separate topics, both of which are very complex. Just building even a simple robot is already complex and hard enough. But the moment you use that word learn in describing your robot, you are adding on a huge, very complex, entirely separate field of study. You are talking very, very advanced robotics. Now, it can be done. Don't let me or anyone else tell you that you can't learn it or even implement it right in your own home or shop. You can. But just understand what you are getting into. You are trying to learn two entirely separate fields of study, both of which can be university courses in and of themselves. It also takes some pretty serious hardware to perform any kind of AI. It can be done on small processors like the Arduino, but the Arduinos are so limited by the power of the processor that it's much more practical for you to make decisions for the processor in advance. And effectively, you just program a series of checks and yes/no actions based on input from sensors. You'll notice that the majority of people learning AI use very powerful processors like Google's AI learning system. You are actually using Google's state-of-the-art processors, which are some of the most powerful on planet Earth. You need that processing power. So what are you going to do? Strap a big fire-breathing desktop computer to your robot? Voice commands and speech recognition are one example of AI. It can be done on your home-built robot, but it's very complicated and requires not just very high processing power, but huge databases. That's why the voice commands on your smartphone will only work if the phone is connected to an internet connection somehow. Your smartphone is not powerful enough to perform the work nor store the huge databases. You are transmitting a recording of your voice to a computer off in the distance, which has incredible processing power and a huge database with which it interprets the sounds to hopefully make some sense of what you are trying to tell it you want. So even voice commands are incredibly complicated to incorporate into a robot. We would normally do this in a hardware hacker kind of way, where we use open source speech recognition like CMU Sphinx or OK Google, which uses powerful external servers. Oh yeah, there, I just woke up my phone.
Here's what I found on the web.
Okay, Google. Thanks.
Wow, it's not for nothing they say Canadians are polite.
Oh, now I can't get this thing to stop. It's Google, they're spying on us! So we use open source speech recognition like CMU Sphinx or OK Google, which uses powerful external servers via the internet with which our robot communicates. Our robot would need a connection to the internet of some kind. It effectively transmits a sound file of speech it wants to interpret, and the speech recognition server sends back the words in a text format. We've programmed our robot to search those words for specific keywords, commands, or instructions, upon which it then acts. So you can see we've gotten away from the need for a large, powerful server computer on our robot, but we've also completely separated the robot from the artificial intelligence because the AI is all happening on the big expensive server way out there in cyberspace, and we don't even see it nor understand what it's doing or how it's doing it. So now many newcomers come into robotics with this impression that they can build a robot that can learn how to do something. Yes, it can be done, but understand it would take years of designing, building, testing, refining, and rebuilding to get even a very simple robot to do the most basic things. And it would take an incredibly powerful processor as well as a whole pile of very advanced programming and an incredible amount of complex math to learn anything. Understand that even just building a small, simple arm robot that sits on a desktop and moves around according to how you flip some switches and control, that little project can take you hundreds and hundreds of hours of work to build. And most likely, you'll have to build several versions before you get one that works. That's just simple electrical and mechanics. Yes, it can be done, and it can be done at home using the simplest of tools and very limited resources. You can do this. So that brings me to my next frequently asked question. I need help building an arm robot. This is an excellent starting point. I commend those of you who start here. That's where I started. Now, while you can use hobby servo motors, like are used on this fancy schmancy arm robot I got from banggood.com. The catch is that hobby servos are generally very weak. The motors on this robot spend most of their energy just holding the robot under its own weight. These also greatly restrict the size of your robot. Plus, you may not be able to buy hobby servos for one reason or another, and this video is devoted to those of you who don't have access to such things. The first thing I would recommend is look at previous designs. Perform a Google image search for industrial arm robot and peruse the many pictures. See what you can learn about the arm designs that are already out there. I actually got to see the first ever computer-controlled industrial robot when I was a teenager, the ASEA IRB-6, which is actually one of the robots I got trained on in college. I also actually own an industrial robot arm. It's a classic 1980s Fanuc robot that was built in collaboration between Fanuc and GM Automotive. It's almost identical to the IRB-6 design. Let's take a quick look at the design because we can quickly learn how it works. There's two ball screw drives at the back, one that leans the robot forward and backward at the waist, and a second one which pulls on the back end of the arm proper, raising and lowering the other end. You can make a quick and dirty screw drive just using a threaded rod I got from the hardware store, some nuts, and by spinning the threaded rod, the nut moves up and down the rod with an incredible amount of force. Connect your load to the nut that runs along the rod. In my demonstration for my Robotics Drives and Physics course, you can see I've actually lock nutted some bearings onto the rod. Those bearings are roller blade wheel bearings, very common and easy to find. So now you just have to take a piece of wood or plastic with a hole drilled in it the size of the outer diameter of the bearing, and you can use a screw or bolt to lock the bearing into that holder, then mount your holder to your robot arm's base, for example. While I have a gear lock nutted on here for demonstration of one way to drive the threaded rod, you can hack a cordless screwdriver, or better yet, a cordless drill. Just tighten the chuck down onto the threaded rod, and voila, you have a threaded rod drive. Now you can't really see the base rotation drive in my Fanuc robot, though here's a picture of the bottom of the robot. It uses a special kind of drive motor called an AC servo motor, and while it's pretty technical and complicated, in my third course I actually show you ways you can hack a common brushless DC motor into an AC servo motor using some high power transistors and a lowly Arduino Uno microcontroller board. Right away, you can start to see the need to learn electronics and digital electronics to even know what I just said there. But again, this can be learned at home at your own pace. To rotate your robot base around, I'd recommend a worm gear drive of some kind, or perhaps a hobby servo which has a nice gear drive in it. Some classic worm gear drives. This is a massive worm gear drive motor that I scammed out of a scrapped photocopier. It's a DC motor, but the motor is at right angles to the drive shaft, the output drive shaft. That almost guarantees that is a worm gear drive. However, another common hardware hack for a motor is a windshield wiper motor or an electric window drive motor from a car. They look a lot like this, actually. Or you could hack various mechanical toys out there, scam the drive mechanisms from them, stockpile these parts, and grab every mechanical device you can. And once you have a stockpile on hand, then designing your new robot revolves around using the parts you have. It's inspirational and incredibly helpful. Collect a stockpile of electromechanical parts. The next frequently asked question, how do I make an RC-controlled robot? This is a good thing, bad thing. Remote control is typically divided up into two categories, infrared or radio control. I would include things like Bluetooth or Wi-Fi under radio control. Infrared is great, except it's pretty much line of sight only. You can bounce the infrared light off walls and go around corners, but in the end it's pretty limited. Hacking the remote control from an old scrap TV or VCR is one way to go about it if you can manage to separate the infrared receiver board from the rest of the electronics, which often you can't do. Radio control can be made from scratch at home, but it's very difficult. You would have to have a ham radio license and follow the laws and regulations in your country. Hacking the radio control from an RC toy of some kind is the way to go if you can't buy RC equipment. But RC radios and receivers have come so far down in price that it is literally worth the money and hassle to just buy an off-the-shelf system rather than try to build one to save money. I understand you're trading off time for money, but in this case you can easily spend hundreds of hours designing and building an RC system that may sorta kinda work. Question number 5, I want to build a flying robot. Usually, such people are referring to quadrotors, or commonly called drones. That's great that you want to do this, and I think you should, but this comes back to radio control and the issues there. And plus, flying machines of any kind consume an enormous amount of power. This requires some pretty careful engineering of the electronics, a very powerful yet lightweight power source, i.e., a LiPo battery or a gas engine driving a generator, and some kind of complex control system, either an onboard computer or radio control or both. All of these things are very difficult to hardware hack. If you're making a multi-rotor, for example, it's very important that all of your motors be identical. Otherwise, control of the aircraft becomes very, very difficult because one motor will be more powerful than the others. So it will want to flip the aircraft over. The motors need to be very efficient, which is why drones almost always use brushless DC motors, which require a complicated driver. There are many reasons why people just buy these drivers off the shelf instead of just making their own. There's also many reasons why people just buy these brushless DC motors rather than make their own. And these motors are typically quite expensive. So yes, it can be done, but you will probably wind up just spending a lot of money, as every single one of these parts is expensive to buy and very difficult to hardware hack or build from scratch. Okay. I've droned on long enough. Hopefully this was somewhat helpful and not too discouraging.